Welcome aspiring data scientists and welcome future Python programmers. Today we have another look at NumPy. In the previous class we started working with NumPy. We did subsetting and slicing of NumPy arrays, and also we learned that we can actually use operators to subset NumPy arrays. The content of today is how we can create a multidimensional NumPy array. That means basically that we put two NumPy arrays together into one. Then we do subsetting of those multidimensional NumPy arrays. And in the end, we also learn how we can use basic statistics and apply it to certain NumPy array ranges. So how can we create a multidimensional NumPy array? We do it the same way we create a normal NumPy array. The only big difference is that this time we actually put two NumPy arrays, or in the beginning two lists, together into one. How do we do it? First, we of course have a variable that stores all of it, and then we apply again the np.array method, but this time we actually include the list price and the list quantity, and we put these in round and squared brackets. Now if we print out the result, you can see that we have here the multidimensional NumPy array, and it stores basically two single NumPy arrays. So we could say it stores NumPy array 0 and NumPy array 1. That stands for the rows in the multidimensional NumPy array, and each of those rows stores 3 elements. And if we now call the pq.shape function, so we want to find out the shape of our array now, we can see, okay, the first number has 2 rows and it has 3 elements. So our multidimensional NumPy array has the shape of 2 rows and 3 elements. And if we want to visualize everything, we can see here we had our first list, or only single NumPy array, and here the second one. And if we combine them, we get one huge multidimensional NumPy array where price is now row 0 and quantity is row 1, and each of the individual element, they have their own column index number. Obviously, we can also subset or slice those multidimensional arrays, and we do this by first defining in the squared brackets the row. So if we put in 0, we slice for the first row of our multidimensional array. If we slice for 1, we slice for the second row. And if we use another time the rounded, the squared brackets, we actually slice for the column number. So first we slice here in this example for row 0, for the first row, and the first column or index number. So first one is always row, second one is always the column. Now let's jump into some examples so you get a little bit used to it. Again, I repeat, first is row, second is column. We can also write it differently. Rather than using 2 times the squared brackets, we can also separate it by using a comma. So first one is row, second one is column. And now we can look here always if everything is right. So let's just have a look at example 4. We can see here's a 1, so that means it's the second row, and we have here 2, so it's the third column. We go here, we can see, okay, first row, third column is 70, so that is right. Let's get into some more examples, because you can also search or select or subset for a range, obviously, and you do this again by using the double points. And the same method or logic applies here as well. So if we want, for example, subset for the first row and all elements within it, you take a 0 and then the double points and leave both sides empty to generate this result. If we want to subset now for the second row and all column elements from 0 until 2, we do this in example 4 by first selecting 1 and then the range of 0 until index number 2. And we know the end is always exclusive, so 70 will not be included in our range. In the end, we have basic statistics. Basically, NumPy has their own built-in or pre-coded functions or methods that you can apply to a whole NumPy array or only to a range. And in this case, you can apply the np.mean to get your average, np.scd to get your standard deviation. Here we get our median. Here we can sum up each individual element together. np.corrcof is the correlation coefficient between two numbers, and np.sort is, for example, sorting numbers or elements from the highest to the lowest. And there are also many other different functions and methods that you can look up in the internet. And again, the logic goes as follows. We apply first our function, then we apply it to a certain NumPy array or multidimensional NumPy array, and then we select the specific element or range that we actually want to focus on. So in this case, we want to focus or get the mean of the first row and all elements. In the second example, we want to have the average of the second row, but again, all elements. And then in the end, in our example 3, we want to have this, want to sum up all elements of our first row, and we get 11.07. So you can really play around with these different functions. So the learning goals that we have achieved is we started working with NumPy. We did subsetting of those single or normal NumPy arrays. And we also did this via an operator. And then in this lesson, we actually created a multidimensional array. We subsetted those, and we also used basic statistics to make small calculations in NumPy. Congratulations, you have finished another video of this online course. Please don't forget to make the NumPy assignment in the Jupyter notebook, and we are looking forward to see you in the next video. Goodbye.